My name is Matthew Pulsipher. I'm product manager at DVIGear, and today we're going to be talking about software-defined MultiViewer, leveraging SDVoE for flexible MultiViewer applications. I'm going to have some case studies, and we're going to kind of talk about how you can use some of the advanced software-defined functionality in SDVoE to do unique things that you can't do with traditional hardware. So first, let's start. Well, what is a software-defined MultiViewer? First, we have to go back to, well, what does the SDVoE stand for? And that's software-defined video over Ethernet. SDVoE transmitters and receivers are powerful, flexible video distribution devices. They are dedicated video distribution hardware whose functionality is completely software-defined. As a part of this, all the NT2000-based devices, such as DisplayNet DN200 series, have an advanced video processor, which includes a frame buffer, a scaler, and a compositor. These components are completely programmable within the SDVoE API, and we can set the video processor to any resolution within the limits of the system, which is 10 gigabits and HDMI standard support resolutions, for scaled streams and for the output of the receiver, which is the canvas. We can talk a little bit about custom resolutions and how you can exploit that for very customized applications a little bit later on in the presentation. So just as SDVoE provides software-defined AV distribution, SDVoE also provides a software-defined MultiViewer with complete flexibility for system programmers and designers, and that is by leveraging that advanced video processor. So we'll talk a little bit about how the SDVoE MultiViewer works. What happens is the scaler component in the transmitter sends a second stream out over the network called stream 1, and this stream is scaled down from the original stream, which is stream 0. The SDVoE API is used to command and control receivers to subscribe to the appropriate combination of stream 1 multicast streams and allocate space for them in the receiver's frame buffer. Then the receiver takes those streams, uses the compositor to composite the streams onto the screen according to the layout that is received from the SDVoE API. The frame buffer is actually a bit larger than 3840 by 2160, so that allows for picture-in-picture functionality. All of the video content in MultiViewer, all those stream ones are completely uncompressed HDMI. It's just been sent through the scaler and the transmitter. So I guess the basis of what comes next in this is I'm going to talk a little bit about the difference between what I call standard MultiView functionality, custom MultiView functionality, and then what I also call advanced MultiView functionality, which is kind of pushing the limits of some of the things that we've done with the SDVoE API in some of our applications. So here's some examples of what a standard MultiView would look like. You have your side-by-side windows, your picture-in-picture, a 3-screen, a 2x2, and even a 5-screen. Some of the dedicated MultiViewer boxes that aren't customizable will come with these standardized type layouts. But SDVoE is software defined, so we're not really limited to those typical layouts, and that's where we bring in the custom MultiView functionality. And to leverage the custom MultiView functionality, there are a few limitations and boundaries which you have to work within. Being software defined, it allows for the custom MultiView layouts. It does come with a couple of caveats, namely that the total receiver bandwidth cannot exceed 10 gigabits because the total system bandwidth limit is about 10 gigabits. That's the physical transmission layer of the platform. You can mitigate this to an extent by using the integrated firmware converter, or frame rate converter, not firmware converter. And that cuts the frame rate in half, which also cuts your bandwidth in half. In most cases, in a MultiViewer application, you don't really need a 60 frames per second signal, so this is a pretty acceptable compromise in most cases. The other caveats that you can't enable compression because compression is exclusively for 4K 60 streams on stream 0. So one thing to keep in mind with your picture-in-picture is that you can't go over the 10 gigabit limit, which means no full screen 4K 60, but you can do a 4K 30 with a picture-in-picture inset, and most video content also happens to be within that limit as well. A couple other limitations, and these are mostly just design considerations. The source streams can't be larger than the assigned frame buffer surface. To give a little bit brief elaboration on this, the SDVoE frame buffer has a predefined surface layout that is suitable for nearly any application out of the box. If you have a very specialized application, you can customize the frame buffer layout, but it's typically not necessary, and if you do need that, you can always contact me and we'll help you set up. There are also several limitations on the SDVoE compositor, primarily to do with horizontal spacing. You can't put, there are certain limits as to the increments as to where you can place windows, and the total number of streams on the screen. With proper design, this is unlikely to happen, and there are certain design tools that we happen to provide, such as DisplayNet Manager, that can help you mitigate this. So there are a couple examples here of what a custom multi-view looks like. A 1x5. We have a large window, and then we have 5 other streams on the side, so you can kind of get a bigger, an emphasized picture while also showing several more streams on the screen. It doesn't even have to make sense because you can literally do anything with the custom. So in this case, we put a picture-in-picture, but we put the pip window right in the middle of the stream. We can also do multiple pip windows, which is something that you can't normally get off of a standardized multi-viewer, like dedicated to hardware, unless it's a very customizable unit, but with SDVoE, it's already built into your video distribution system. So let's talk now about what I call advanced multi-view functionality, which is a step above custom. This is where you want to extend the limits a little. For some applications, a custom multi-view layout, just the ability to put windows wherever you want on screen, isn't sufficient. Things like digital signage, you may have sources with unusual resolutions or displays with unusual resolutions. And I'm going to cover a couple of real-world case studies that we've done in our own applications that we've deployed DisplayNet with. Case study number 1. A customer needed to show a combination of odd-size resolution sources on a single 4K monitor. I believe those boxes were 600 by 600, they had a 720 source, and some 1024-768 sources. They need to have minimal scaling, lossless quality, and the sources needed to be synchronous because it was a monitoring application. So we had a blend of different aspect ratios, and they needed to be all on one screen because previously they were needing to bring 7 different monitors, or 5 different monitors, or six different monitors in this case, to their trade show just so they could get a monitor on each individual source, and they couldn't find a hardware multi-viewer device that could do that. So this was pretty easy using DisplayNet Manager because we enable the custom resolution Windows services in our multi-viewer editor. We can set them to any width or height needed as allowed by the SDVoE standard. And as I had said earlier, there was no dedicated multi-viewer device that could do exactly what they were looking for with this. In fact, this is one of the only systems we've ever sold that only has one receiver. They bought a matrix switcher with one receiver just so they could have the custom multi-view functionality that SDVoE can provide. Another case study for kind of an advanced multi-view that we've done was a customer that was implementing KVM functionality as a part of a much larger system. They were replacing workstations that had 2 separate 1080p monitors that needed to be independently routable. It couldn't just be connected to the local workstation. So they didn't want to buy 2 receivers, which was kind of a bummer for us, but we decided to work with them anyway. So what they did instead was they got a monitor that was 3840 by 1080 and then used the multi-viewer to have a dual display input. And this actually gave them quite a bit of flexibility because they could also route that 3840 by 1080 monitor as a single monitor to any computer in the system. It gave them a lot of flexibility, and the multi-viewer was able to support any type of source sent to that second virtual monitor on the double-wide display. The latency is a little bit higher than the other modes of SDVoE, but it was still sufficiently low for the type of KVM usage that they were using. And again, the receiver was independently routable for a single workstation with a double wide, with native gen-locked support with the 100 microsecond latency that SDVoE is so famous for. So to achieve this, we used our API to set a custom canvas size, which is something that you can absolutely do when you start taking charge and really leveraging what the SDVoE API can allow you to do. So to give a little bit of detail as to how that works, I'm now going to talk about how our product leverages the very flexible SDVoE API to perform these advanced multi-viewer applications. So first off, something I wanted to say, all SDVoE hardware that supports multi-view can support this level of customizable functionality. It's a part of the standard. any SDVoE box with MultiView support can do these things. The DisplayNet hardware just happens to be fully standards compliant, and we keep it up to date with the latest SDVoE firmware, so that's never really an issue. Most SDVoE solutions do limit MultiView to an assortment of pre-made layouts, whereas we have full-featured support for custom MultiView layouts in the UI, but also the API. You can programmatically create layouts with the API that we've created. Now, why is it so common that you would have this advanced MultiViewer functionality and then limit the integrator to pre-made layouts? Well, the SDVoE API is a very good platform. It's very flexible. It can support those kinds of applications that we discussed earlier, but it can be quite complex to use, especially on an integrator layout for MultiViewer applications. A single MultiView route can take dozens of SDVoE API commands to execute. As each transmitter scaler must be configured, you need to start the second stream and then route it for each of the windows on your receiver. So if you're routing multiple receivers, that can take a lot of commands, which makes it a little bit hard to automate. And truth be told, this isn't necessarily a bad thing. This level of granularity is incredible for advanced programmers and manufacturers such as us. Because it allows such advanced functionality and it gives you that level of control. But it puts an undue burden on system programmers, and it may be impractical when you're implementing automation systems because generally to keep processor load down, you don't want to be sending out a ton of commands. So to give a bit of a rundown of how we manage this, as well as the UI that we have to support this type of functionality, we have a full-featured GUI for custom multi-view layout editing. We support custom window sizes, as I showed earlier with the square multi-view windows. We have a grid alignment system that you can toggle on or off to enable clean lines between your windows. It facilitates the creation of layouts. And it unlocks the full potential of SDVoE's multi-viewer functionality without ever having to touch a line of code. Once you have your layout, setting up the configuration so that the video streams can go to each layout is very easy. You just drag your sources to the destination windows and your configuration is saved as a virtual device in the routing list. And you can route it to any multi-view compatible receiver with just a few clicks. Or, if you're building an automation system, which the majority of applications are, we also offer the API. Something that's very unique about DisplayNet Manager in particular is that we use the same API that we expect integrators to use. So when we design this, we design it to be easy to use for us so that when you roll your projects out, it's easy to use for you. So what we do is we have this console tab, and everything you do in DisplayNet Manager, we give you the command that was executed by DisplayNet Manager to perform that task. And that even includes multi-view layout configuration and multi-view configuration assignment. But if you've already configured your layouts and configurations in DisplayNet Manager, you can route a multi-view with a single command, mtv connect. And we take that configuration, we're going to route it to the lower left monitor in this example. That said, let's say you did want to get your hands dirty and get into the SDVoE API and do something that our UI doesn't allow you to do. We let you do that. If you have native SDVoE control commands, you can send them directly into the DisplayNet API in the same session that you're using DisplayNet API commands, and it will take those natively. It allows for extreme system control and customization for those with very specific application requirements. Custom canvas is an example. So, in summary, the SDVoE multi-viewer functionality is incredibly flexible and powerful. The custom multi-view layouts enable SDVoE to be used in many applications. However, advanced multi-viewer functionality, when you start talking about custom canvas and window sizes, which is all enabled by the amount of flexibility that the SDVoE API gives you, is a true game changer. And it can unlock many new possibilities for custom integration, building applications we haven't seen before because the previous hardware wasn't capable or customizable enough to do it. And DisplayNet's easy-to-use UI and versatile API provides system integrators with the powerful tools needed to be able to leverage this functionality for any application. And I would like to thank you all for coming to my talk. Our stand is 1M100, and you can find out more about us at displaynet.com. Thanks.